Hello, my wonderful math students. Today our video is going to cover how to model equations. So if you look at this example that I've put up on the board, if you remember in class today we did that pan balance. So this right here would be considered your balance or your equal sign. And so you've got two separate sides. You've got this side over here and this side over here, and you need to keep them balanced. And we're going to talk about how to do that moving forward. Our target is to represent relationships with tables, graphs, rules, and words, but also to solve one- and two-step linear equations with one variable, and to solve practical problems requiring the solution of one- and two-step linear equations. So if you remember back when we were talking about our integers, and we did all of those things, and we had the counters. And with those counters, our white counters were positive and our red counters were negative. If you remember that, when we put them together, we used that and called that a zero pair, because if I have +1 and -1, I have one and I take one away, that equals 0. That is our inverse property of addition. So we're going to be using that inverse property of addition to model equations today. So take out your notes. You're looking at the top says modeling equations, and we're going to quickly jump in and we're going to take the notes on the right side, and then I'm going to explain what the notes on the right side mean. So if you look at this notes over here, when we talk about our steps, our first step whenever we're modeling equations is to identify or write the equation. So we're going to look at the picture. We're going to use the key that's here, and we're going to identify what is the equation that we have to solve. Then when we want to solve it, we're going to use the inverse property. Remember, that means upside down and inside out. That's what inverse is all about. That means that we add the opposite. So that's +5, -5. We've got a positive and the same number as a negative, and that equals 0 to make those zero pairs. But if our operation is multiplication, then we're going to multiply by the reciprocal, or that's that flip where we flip the fraction upside down. So 1/2, the reciprocal would be 2/1. We're multiplying by 2, and we get 1 as our answer. So those are using the inverse property. And the last thing that we have to remember is the golden rule of algebra, and that is whatever we do to one side of the equation we must do to the other. Or the other side. So with equations, the fact that they're equal means we have to do the same thing on both sides to keep them equal. When we were doing the pan balance in class, where we were going through and trying to figure out what each shape equaled, we had to do the same thing, to get it level. So that's what we're going to be doing. So let's look at these examples that we have. The first one says, what is the solution to the following model? Well, if we look at our model, we have this long shape here, and if we look at our key, the key says this long shape is equal to an x. So I'm going to put that is an x on my paper. Then I have two white squares, and if I look here, that white square means a -1, so that's like a negative and a negative. If I have two negatives, that's -2. And then I have 1, 2, 3, 4, 5 negatives here, so that's a -5. So if I use those pieces, I can write my equation. So I have 1x, and I have -2, and I have my equal sign, and then I have -5. So my equation is just simply saying, counting the boxes, or in this, what we were used to were chips. Now sometimes they're boxes, sometimes they're circles, sometimes they're gray or black or white, and we have to just use the key to figure out what each one means. Now, the second step, we just wrote our equation. Our second step is to come back over here, and number 2 says use the inverse property. So if we look at our equation, we're subtracting 2 or have a -2. So to do the inverse, that means I have to go to the opposite colored square. So if these were white, then I need to draw 2 dark squares to make 2 0 pairs. And what my golden rule says, whatever I do to one side, I have to do to the other. So I'm going to come over here and draw 2 dark squares on this side. So now my equation is equal. My ultimate goal is to figure out what this x is by getting it by itself, which is why I have to make these 0 pairs right here. So if I have a positive 1 and or a positive 1 and a -1, that makes a 0 pair here. This makes a 0 pair here. This makes a 0 pair here, and this makes a 0 pair here. Now I have my x by itself on this side, and on this side I have 3 negatives left. So that means that my equation is, or my answer to my equation, my x I know has to be -3 because there's 3 negatives left. Now, if you want to watch what I do, I'm going to go ahead and show you what I'm doing mathematically, because we're going to model, but then we're going to eventually move into a place where we're not using models and we're doing it just mathematically. So I'm going to write really small. We have x minus 2 equals -5 was our original equation. And we came over here and we added the positives. We added 2 positives to each side. Those are those colored in the dark bricks. And once we did that, we made 0 pairs because a -2 and a +2 equals 0. So I have x plus 0 equals, and if I have, remember your battle boxes, a -5's in the negative box, +2's in the positive box, which box has more than negative? And how much more? 5 minus 2 is 3. And I know that from my additive identity property, anything plus 0 is just itself. So I can actually come back and erase that plus 0 because anything plus 0 is just x. X plus 0 is just x. So now I have x is equal to -3. So my math side, or my math work, matches what I did on my model. So that was an equation, that was a one-step equation, which means one operation, and our operation being done here was subtraction. So we undid it by adding to each side. Now if we look at our next model, this one says I've got 2 of these cups over here, and each cup is a C. So here's a C and here's a C. So how many C's do I have? I have 2 C's. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on this side. And I look over here to my key, and they're dark circles, so that means they're a positive 12. And to find out how many of these chips are in each cup, I need to split them up. So I'm going to say that this is my red cup. Make that my red cup. And let's see. If that's a red cup, 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 that's a red cup. There's 6. So here's my red cup ones. And I'll make this my blue cup. And here's my blue cup chips. So what I did is I took them and I divided those 12 in half because there were 2 cups. So I needed to split it so each one got the same amount. And since there was 2, I divided by 2. So if we look at how we're going to solve this mathematically, we have 2 cups. And I told you I was splitting it in half, which is using the multiplicative inverse or flipping it upside down. I'm multiplying by 1/2. Remember, any whole number I can put over 1 to make a fraction. So 2 times 1 is 2. 1 times 2 is 2. That 2 over 2 is the same thing as 1. So these cancel out because I'm just left with 1c, which is what I want to know, is how much is in 1 cup. On this side, I have 12 times 1 is 12. 1 times 2 is 2. So my ultimate thing that I'm doing is dividing by 2. When I multiply by 1/2, I'm dividing by 2. 12 divided by 2 is 6. So I know that 1 cup is going to hold 6 chips, which is what we got when we divided them into separate cups up here. So, and I know this is very confusing and we go through it fast. Most of the time on your SOL, they're going to give you a model and they're going to say find the solution. You have to be able to write the equation from the model and then solve it, whether you do it using the model or you use it doing math. It doesn't matter, but I'm showing you how to use the model because some of you it may help. All right, that was one-step equations, which means we have one operation. Now we're moving on to two-step equations, which means that these are going to have 2 steps. And those 2 steps are always going to be either multiply and divide or addition and subtraction. So you're going to have a combination of both. So again, our steps, let's review our steps. First step is to write the equation, which we're going to do in just a minute. Then we're going to use the additive inverse, which means adding the opposite. And when we say add the opposite, we mean positive or negative. And then the next one is using the multiplicative inverse, which means using that flip. So we're multiplying by the flipped fraction. So if it's 2, we put 2 over 1, and we multiply by 1/2, and that gives us 1. So when we're solving equations, it's important to know that we use the order of operations in reverse. That means that our order of operations are normally parentheses, exponents, multiply and divide, and then add or subtract. We are going to go from the bottom up. So we're going to add or subtract first, then multiply or divide. So if we go back up here to our example, let's look at what we have. Use your key. We have 3 triangles, and each triangle is a T. So if we have 3 triangles, that means we have 3T. And then here we have 1, 2, 3, and these are positive, is where I got the positives. So that is a +3. Over here we have, I won't be able to write this because they're dark, but 1, 2, 3, 4, 5, 6, 7, 8, 9, and they're negatives. So think of these as 2 different sides. I've heard it said that they're different sides of the river. So I'm going to pick up a red pen because we associate the negatives with red. In order to make a 0 pair, to get the T's or the triangles by themselves, I have to use the additive inverse. So if it's +3, I need to add my -3. So I'm going to add a negative circle here. That's my negative. And I'm going to add one for each positive chip I have. So now I have a negative and a positive, which equals 0, another negative and positive, which equals 0, and another negative and positive, which equals 0. So each of these equals 0. Whatever I did to that side, I now have to come over onto the other side and do the same thing. Make sure that you're adding the same number that you added on the left onto the right and that they're the same color. Don't switch the color because these are dark over here. You have to add the same color and the same number as you did on the left. So now I have 0, just 3 t's here, because we can basically say, okay, these are gone because they're now 0, and I have 3 t's here. Over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have 12 negatives because these are -2. Now my job is to, remember when we had our groups for multiplying and dividing, we have to take those 3 t's and figure out how many of these circles, these negative circles, are going to fit into each t. So if you think about it this way, I have a red one. I'm going to make this T green. I'm going to make this T blue. That way I can distinguish when I separate them. So if I make this one red, this one green, I'm basically taking them and dividing them into groups. You know how when teachers take you and say, count off 1, 2, 3, 1, 2, 3, 1, 2, 3, that's what I'm doing. So I'm taking each one and saying, okay, this is a red one. You're going to the green group. You're going to the blue group. You're going to the red group. You're going to the green group. You're going to the blue group, green group, and of course the red group. So if we look at it, we ended up with the same amount. So think of it as each of these columns is a triangle. So here's one triangle, here's another triangle, and here's another triangle. So how many are in each triangle? Each triangle is going to be equal to 1, 2, 3, 4, and each 4 is colored dark, so they are a negative. So that's how we're doing it. With this one, we started with getting rid of the 3, which is the constant or the number by itself, by adding the inverse, which was -3. Let me show you. I'm going to erase your answer for just a second and show you what we did. So we had 3t plus 3 equals -9. Here's my two sides of the equation. So I got rid of this plus 3 by adding 3 negatives. When I did that, a 3 and a -3 equals 0. So I can just get rid of that. It equals 0. Anything plus 0 is going to equal the same thing, so I can just bring down what's left, the 3t. Over here, I had, when I counted all those up, I had -12. If you think of your battle boxes, the -9 goes in the negative box, -3 goes in the negative box. They're all in the same box. We just combine them or add them together. Now I have to split that -12 into 3 groups. So I'm dividing, this means divide, this bar now, dividing by 3. 3 divided by 3 is just 1t. And -12 divided by 4, or sorry, divided by 3 is going to give me 4, and negative divided by a positive is a negative. So that's how we got our answer. So our answer should be t is equal to -4, and it works both with the math and with the pictures. Let's look at our next one. Again, this is a two-step equation, so we're going to have multiple variables, and then we're going to have addition that we have to get rid of as well. So if we look at our example, each of these canisters is an X. So our first step is to write our equation. How many X's do we have? We have 4 X's. If we look here, we have 2 black squares, and if I come over to my key, each black square is a -1. So that's -1, -2. So I'm going to write that as -2. And on my other side, if we divide our equation, got my equal sign, I have 1, 2, 3, 4, 5, 6. I have 6, and those are positive. Now, to undo that negative, because remember we want to get our x's by themselves first, we have to undo these negatives that are here. To undo the negatives, I'm going to use the inverse, which is the positive. So I'm going to draw a white square for every dark square I have to make a 0 pair. So now I have a negative and a positive here, which is 0, and a negative and a positive here, which is 0. Whatever I do to the one side, I have to come over and do the same exact thing over here. I added 2 positives, so now I have to, oops, I have to add 2 positives here. Sorry, I deleted my positives. So now I'm left with 4 x's and I have 8 positives. So that would be written as 4x equals 8 positives. Now I have to take that and split them up. So how many would be in each canister? Well, if you think about it, I could divide them up by color and say, okay, or I can look, is there an easy way that they're already divided that I could easily say, oh, there's 1, 2, 3, 4. If I think about it, here's a canister. How many's in that canister? Here's canister number 2, canister number 3, and canister number 4. So each one has how many in its canister. According to our picture, we have 2 positives in every canister. Well, if you look at mathematically, what did we do? We started by adding, using the additive inverse. We added 2 to each side. So here is 0 now, and we're left with just 4 canisters, or 4x. When we added those 2, we got 8 on this side. Now I have to divide those 8 into the 4 canisters, so I'm going to divide by 4, or multiply by 1/4. When I do that, I get 8 divided by 4, which is 2. And that is my answer. So I know we went through this pretty fast, and it is confusing. We will continue to go over this, and over time you will get it, but it's a new way of thinking for your brain. So if you don't get it right away, that's okay. Here is, we're going to do the first one and the third one, and then I'm going to have you guys try number 2 for your Edmodo quiz. If you look at the first one, you have to ask yourself, what is the operation being done? I'm adding a negative or subtracting, so I'm going to use the opposite. The opposite of subtraction is addition, so I know I'm going to undo this one with addition. So we have 1x, so x is represented by a canister, so we're going to draw a canister. If your picture is not pretty, that's fine. We have 1x, and then we have 5 negatives, and the 5 negatives are represented by dark squares. So here's 1, 2, 3, 4, 5. Then I have my other side of my equation, and on that side I have a negative 2, which means I have 2 dark squares. Now, to undo it, I just said the opposite of subtraction is addition. So I have to use the additive inverse, which means I have to draw the opposite color square. So if these are dark, I have to draw white squares. And I have to draw as many as I have on the side with the X. So in this case, I have 5 dark squares. I need to draw 5 white squares. Whatever I do to one side, I have to do to the other to keep it even. And since I added 5 white squares, I have to add 5 white squares over here. Now I'm going to go back and I'm going to cross out my 0 pairs. So this is 0, this is 0, this is 0, 0, 0, 0, 0. And now what am I left with? I have 1 canister, and 1 canister is going to be equal to 3 white squares, which means a positive 3. So 1x is equal to a positive 3. I'm not going to ask you to do the math on this one. I'm just asking you guys to go through and try to use your pictures to solve. Okay, let's scroll down. I'm going to let you do 2t equals negative 10 and try to solve it. and you can draw your pictures on your paper, but I'm going to have you give me what you think t is equal to on your Edmodo quiz. On the next one, we're going to draw, this is a two-step equation because I have both multiplication here with the 3x, and I also have addition with the positive 2. So use your key. Each x is represented by a long bar, so I have to draw 3 of them. 1, 2, 3. There's my 3x. Each one of those is an x. Now I have a positive 2, and positive 2's are dark squares. So here's 1, here's 2. And that is equal to negative 7, and 7 is represented by white squares. 1, 2, 3, 4, 5, 6, 7. Okay. Now I have to solve. In order to solve, I start by undoing the addition. Remember, that's order of operations in reverse. So in order to get rid of the dark squares, I have to add the opposite color, which are the white squares. So I'm going to add a white square here and a white square here. Remember, whatever I do to one side of the equation, I have to do to the other side. So I'm going to go through and add those two white ones on this side. Now go through and get rid of your zero pairs. I have a positive and a negative here, positive and negative here. So all of these are gone, and I'm left with just my 3x on this side. Do I have any zero pairs on the other side? I do not, because they're all white, so I'm just going to add them up together. So now I'm left with 3x here, and 1, 2, 3, 4, 5, 6, 7, 8, 9 negatives on this side. Now I have to figure out how many is going to go in each x. So if you want to, you can color code them again like I did before and say, okay, I've got a red one, I've got a green one, and I've got a blue one. And go through and color code each of them. So if this one's blue, and this one's green, this one's red, do it again. Now I've got a red one. Now I've got a green one. I've got a blue one. Now I've got a blue one. Now I've got a green one. And now I've got a red one. So now if you look at it, how many are in each color? I've got 3 red ones. So there's 1, and I've got 3 green ones and 3 blue ones. So x is equal to a negative 3 because each one is white, which means it's negative, and there's 3 that goes with each color. Okay, so that's the end of our notes, and I know I went over them quickly. If you need to rewatch the video, you're going to be responsible for finding the solution to this, the one on the left that's got the cups with the circles, and also modeling and solving the equation that's on the right with 3x minus 1 equals 5, in addition to 2t minus negative 10, or equals negative 10, sorry. And like I said, if you're confused, we'll go back over this a lot in class, so don't be worried. We're going to have lots of practice, and we'll break out some manipulatives so it'll help you understand, and I'll give you some real-world situations. Have a good evening, and I will see you next class.